Loading. Physics Art Integration Project by Aditya Verma explaining few concepts of physics through animations. In this video we will be covering 3 concepts of the chapter Current Electricity. The first is Ohm's Law, then Kershaws Rule, and finally Wheatstone Bridge. Ohm's Law, discovered by Georg Simon Ohm in 1827. Ohm's law states that the current through a conductor is proportional to the voltage across the conductor. This is true for many materials provided the temperature remains constant. V is proportional to I. V equals IR, where V is voltage, I is current, R is resistance. Now, to understand the relationships of the quantities in Ohm's law, it is often helpful to consider a water current analogy. In a water circuit, the force to move the water is supplied by a pump. The rate of water flow depends on the resistance to the flow. Example, due to some obstruction in the circuit pipe, the greater the resistance, the less water flow. Analogously, in an electrical circuit, a voltage source, example, a battery or power supply, supplies the electromotive force for current flow, and the magnitude of the current is determined by the resistance R of the circuit. For a given voltage, the greater the resistance, the less current passes through the resistor, as may be seen from Ohm's law, I equals V, R. Notice that source supplies a voltage, rise, that is equal to the voltage, drop, across the resistor and is given by V equals IR. Any component in a circuit that does not generate or supply a voltage acts as a resistance in the circuit. This is true for the connecting wires, the ammeter, and voltmeter. However, the metallic connecting wires in the ammeter have negligibly small resistances, thus they do not significantly affect the current. Also, a voltmeter has a high resistance, so very little current flows through the voltmeter. Hence, to good approximations, the ammeter registers the current in the circuit and the voltmeter reads the voltage drop across the resistance. These approximations are adequate for most practical applications. Kershaws Rule, discovered by Gustav Kirchhoff in 1845. Kirchhoff's first rule. This law is also known as the junction rule or current law. According to it, the algebraic sum of current meeting at a junction is 0. If a current comes out to be negative, the actual direction of current at the junction is opposite to that assumed. I plus I1 plus I2 equals 0 can be satisfied only if at least one current is negative, that is, leaving the junction. This law is simply a statement of conservation of charge, as if current reaching a junction is not equal to the current leaving the junction, charge will not be conserved. Now, moving on to the diagram. Here a simple junction is drawn where current from 2 directions are coming, that is I1 and I2, and I4 and I3 are leaving the junction. The amount of current entering the junction is equal to the amount of current exiting the junction. I1 plus I2 equals I3 plus I4. Kirchhoff's second rule. This law is also known as loop rule or voltage law, and according to it, the algebraic sum of the changes in potential in complete transversal of mesh is 0. The law represents conservation of energy, as if the sum of the potential changes around a closed loop is not 0. Unlimited energy could be gained by repeatedly carrying a charge around a loop. If there are n meshes in a circuit, the number of independent equations in accordance with the loop will be n-1. In the following closed loop, I2R2 plus E2 plus E3 equals I1R1 plus E1 plus I4R4 plus I3R3. Then we get minus I1R1 plus I2R2 minus E1 minus I3R3 plus E2 plus E3 minus I4R4 equals 0. Wheatstone Bridge, discovered by Samuel Hunter Christie in 1833 and named after Charles Wheatstone. The history of the Wheatstone Bridge. The Wheatstone Bridge was invented in 1833 by Samuel Hunter Christie, later named after Sir Charles Wheatstone for his many applications of the circuit through the 1840s. It was the most common procedure for the testing of the unknown electrical resistance. How does it work? It uses the ratio of 3 known resistors, measures 4th unknown resistance, balanced voltage between 0.1 and battery's negative, and between 0.2 and battery's negative allows the measurement. By changing resistors to adjusting variable resistor to balance the device, the mathematical ratio is used to calculate for the fourth, unknown, resistance. The current enters the galvanometer and divides into two equal magnitude currents as I1 and I2. The following condition exists when the current through a galvanometer is 0. I1P equals I2R. The currents in the bridge, in a balanced condition, is expressed as follows. I1 equals I3 equals E divided by P plus Q into I2 equals I4 equals E divided by R plus S. Here, E is the EMF of the battery. By substituting the value of I1 and I2 in equation 1, we get PE divided by P plus Q equals R divided by R plus S. P divided by P plus Q equals R divided by R plus S. P R plus S equals R, P plus Q, PR plus PS equals RP plus RQ. PS equals RQ. R equals P divided by Q times S. Equation 2 shows the balanced condition of the bridge, while 3 determines the value of the unknown resistance. In the figure, R is the unknown resistance, and S is the standard arm of the bridge, and P and Q are the ratio arm of the bridge. The end. Thank you for watching. The runtime is 6 minutes and 19 seconds and the average runtime is 6 minutes and 10 seconds. Closing now.